Hello, we are Team Sudo RM, and we have created a MIDI, a digital audio workstation that allows you to import MIDI files and create your own song files and export them as MIDI files. Here's how we did it. Tony?
Hello, my name's Anthony Carr. I worked on the back end of this project. So, a couple of things I want to go over. Basically, what I did. So, what I did in detail is I made the synthesizer. Now, the synthesizer in and of itself was a difficult task to overcome, but we eventually ended up making something that worked out really well. Because of the way that we set up the synthesizer now, instead of the previous way, we're processing it in low latency real time rather than pre-processing. It allowed us to play a lot of notes at the same time. So I could feed in a lot of different notes to the DAC, and it would play back all the notes at the same time. That helped us out a lot whenever it's coming to create this. Rather than having to process all of the notes together in one sound wave, we could feed it multiple sound waves, and the DAC would figure it out. We are also able to, whenever you play the sounds, you can now edit the synthesizer in real time to make it sound different. So that was another advantage of the real-time to DAC synthesizer that we ended up implementing. The user doesn't necessarily interact with my portion of the project specifically, but through various means they are able to access it, obviously by playing notes and stuff like that. So I actually didn't have any tests to run, but my portion of the code was involved in all of the tests. So we're going to go through those later.
Hi, my name is Joshua Gare. I worked on all the front end, in which I created this grid that you can see here, the creation and deletion of notes, and the piano roll, along with the coloring of the whole UI. Along with this, I made little menus for if there is no note, you can right-click, and it brings up menus to add a custom size note, to add number of measures, and to add a tempo, to change the tempo. So for my design rationale, basically all of these grids, like each and every single grid, it's a piano roll staff object, and this giant thing is hosted by a class called piano roll. So each of these grids have various parameters, such as like what note it's mapped to, the name of the note, is it hovering, various things like that. And then once you create a note, you can like specify the size up here. So a half note would be like this size. For the test planner and tracker, for note creation, I just made sure that each note worked, like each note length worked when clicking, and it created it in the right space. I stress tested it for multiple sizes just to make sure it'll like work no matter how long you paint the note.
Hello, my name is Ephraim Jackson, and I worked on the back-end data storage correlating with the front-end piano roll, as well as getting the notes to play back in real time based on what was drawn on the screen. So most of my work was just getting the two individual components that Tony and Josh worked, getting to communicate together and working as expected. And I also made sure that whenever you hit the play button, the notes that played were accurate in pitch, accurate in time, and that the loop played properly. So the design rationale, I actually had a little bit of fun with this one. So the most significant thing that I had decided for the design of this project was the storage of the notes. So the notes are actually stored within the track as a map, and the map has at each index a vector of all the notes that are played at a given start time. So it's mapped by start times, which are integers that are in increments of 20. Because of the way that Josh set up the piano roll, each of these little 16th squares is a value of 20. So it's mapped in intervals of 20 and has all of the notes that play at a given start time in that note map. And so what that allows us to do is more quickly search through the notes that we need to play at a given time, because we only need to search the notes that are currently going to be played. We don't have to search everything, and it won't bog down our program as it gets exponentially large. As far as testing the playback use case, which is my responsibility, as well as the pause use case, all I really did was add a bunch of gibberish notes or random notes to the piano roll, play it back, make sure it was in time and what it was represented of, and then I paused it, made sure it retained its place whenever I unpaused, and then made sure everything looped properly. So I basically just stress tested by adding a bunch of notes and making sure everything was still in order, no matter how I added, deleted, or modified the notes.
Hello, my name is Cameron Donner. I implemented the save and load operations for MIDI. So if I were to open the load operation in the file menu of MIDI and go into our projects folder, I'd be able to load a song that one of us made earlier and play it back. And if I wanted to save the same file or save any data that I made on my own, all I would have to do is hit save, and then as you can see, it shows untitled.smf, and then I would go back into my projects folder, and I would just need to name the file something different, but I'm going to leave it as untitled now. So now that will hold the same data that we just loaded back, and whenever we hit the load button, it will clear the screen of the data that already existed, and when we load in untitled.smf, it'll be the same data that we had before. That's the basics of how the save and load work, and for the purposes of MIDI, that's what we saw fit the project appropriately. The four things that I was meant to cover in Test Planner and Tracker were the first four, the save and load operations. All of these work directly as expected with no issue. We tested them by constantly saving and loading over and over again and making sure that no data was lost in the in-between.
My name is Todd, and my role and my tasks for this project were mainly going to be the import and export of MIDI files into the software, as well as the tool selection and configuration for getting all the code done. The main challenges to this was adapting everyone to use the same software that none of us were very familiar with, as well as the fact that MIDI files are very dense and not easy to work with directly, and as such it's a real challenge in order to get everything to work congruently and simply together. To import, you go to File, Import, you select your MIDI file, and it will auto-populate all the notes in the MIDI file. Everything is imported as it is in the file, and is ready to play whenever you feel like it. And to export, it is very simple. You just go to File, Export, navigate to your destination, name your file, and click on Save. For the test cases, I was responsible for 4 individual test cases, 2 for import and 2 for export, just regarding general functionality. All 4 are completely passing, and they were tested by continuously importing and exporting the same MIDI file and retaining the same information in the file.